All right, let's go over the Unit 2 review sheet. So this is the proton, neutron, electron chart. Let's take a look at this first one. It says we know we have 11 protons. Well, the number of protons, the atomic number, are always the same. That's going to be number 11. You'll recall that the mass is equal to the proton number plus the neutron number, because electrons have no mass. So if I know the mass is 23 and I have 11 protons, so basically what I'm doing is this: 23 equals 11 plus x. So we need to determine what x is. You subtract 11 from 23, there are 12 neutrons. Number of electrons is going to be neutral because there's nothing indicating this thing has a charge, so the electrons and protons will be equal. I look at my handy-dandy periodic table and I notice that the atomic number 11 is going to be sodium, symbol is Na. Mass goes up here of 23. Atomic number of 11 goes down here, no charge because there is no difference in the proton and the electron number. Okay, the next one, atomic number 15, so we know there are 15 protons. And since we knew there were 16 neutrons, if I sum these two, 15 and 16, well, that's 31 is your mass. Nothing indicating this thing has a charge, so it should have 15 electrons to balance those 15 protons. I look at my periodic table, number 15 is phosphorus, 31 goes up here, 15 goes over here, no charge. Okay, this one, I have a charge, so we have to remember that the electron number is going to be different for this one. 35 is the atomic number, because it's written below, and then 80 is the mass. It's the big one on top. Okay. Number of protons will be equal to the atomic number, 35. Number of neutrons, so once again, if I know this is 80 and this is 35, if I subtract that, that's going to be 45. 45 and 35 will sum up to give you 80. Number of electrons, so this is -1. That means I have one more electron than proton, because electrons are negative, protons are positive. If this is 35, this has to be 36. Okay, next one, atomic number is 13. Mass is 27. Okay, I should have 13 protons. And then for the neutrons, 13 and 14 add up to 27. Notice in this instance I have a 3 plus. That means I have 3 more protons than electrons. If the protons are 13, the electrons have to be 10. Okay, this last one, notice it is neutral again. There's no charge. So atomic number is 5, mass is 11. We have 5 protons. 5 plus 6 is 11. No charge, so 5 electrons. And that's how you do that chart. What distinguishes atoms of one element to atoms of another? Number of protons in the nucleus. Okay. That's, if I have 6 protons, it's carbon. If I have 7, it's nitrogen. 8, it's oxygen. All right. So the number of protons is what determines what the element is. How do you calculate the number of neutrons in an atom? So that's that same thing we were just looking at. If you know the mass and you know the atomic number or the number of protons, all you have to do, so like, let's pretend that this is, 24 and this is 12, and we don't know the neutron number. All you do is subtract the protons from the mass. Okay? How do you calculate the number of electrons in an atom? So once again, if it's neutral, meaning it has no charge, the proton number is equal to the electron number. Okay? If you have a negative charge, the number of protons is going to be less than the number of electrons. If you have a positive charge, the number of protons will be greater than the number of electrons. Okay. Number 5, how do isotopes of a given element differ from one another? Isotopes have different masses because they have different numbers of neutrons. Okay. How are they the same? They have the same number of protons. So they're the same element, but they have different mass because they have different numbers of neutrons. Okay, let's take a look at this chart. Let's see. Why is that? There we go. Okay. Electrons, they're found out in the cloud. You could say out in orbitals. You could say the electrons are in energy levels or shells, many words, but they're found outside the nucleus. They're symbolized like this, E with a minus sign above it. They have a -1 charge, and they have no mass. Okay. Protons are found in the nucleus. They have a symbol of plus. They have a charge of plus, 1 plus, they're positive. And they have a mass of 1 AMU, 1 atomic mass unit. Neutrons are also found in the nucleus. They're symbolized with a lowercase n. They have no charge. They are neutral, but they also have a mass of 1 AMU. Okay, the atomic models. I'm going to talk about them in order, all right? So this one would be the first one, okay? This is going to be the model that was come up by that Greek philosopher Democritus, where he said that atoms were small, hard, indivisible spheres. Okay, so it's like you could take matter and you could chop it in half and keep chopping it in half and half and half until you couldn't do it any further. And that was the atomos, the indivisible. And so that was the first kind of model of the atom. That was over 2,000 years ago. Next, this is going to be the second one. So this is Thomson's plum pudding model. Okay. And so this is the first person that came up with the idea that there were things that were smaller than an atom. Okay, there were these subatomic particles. And what Thomson noticed was that he was able to detect that there was negative charges in atoms. And so he originally called these things corpuscles, and they changed to electrons. But he gave the analogy of being like, he called it the plum pudding model. Plum pudding's kind of like a blueberry muffin. So he said like the muffiny part is positive, and then like the blueberries interspersed throughout are negative. And so that is the second one. That was in the late 1790s. The next model is going to be this one. Okay. And so this is going to be the Rutherford model, or the one that he used coming up with this thing called the gold foil experiment. So what Rutherford noticed was that there was also a positive part of the atom. Okay, he was using an experiment where he had a sheet of gold foil, some thin gold foil, and he was shooting these positively charged alpha particles at it. And he noticed that occasionally, you know, he would, as he shot these alpha particles, they'd bend away and sometimes they'd ricochet straight back. And so Rutherford kind of made some inferences from his experiment. He said, okay, the atom is mostly empty space, but there was a tiny dense center where almost all the mass was, and then that center had a positive charge. So basically, he discovered the nucleus. The fourth one is going to be this one. This is Niels Bohr, his model. Okay, and so Bohr's model was different from Rutherford's because it showed that the electrons had some kind of order. In Bohr's model, they were they were in specific orbitals. In Rutherford's, they're just willy-nilly wherever, floating around outside. So Bohr noticed that the electrons had, specific energy levels, and he said that the electrons were free to move between these energy levels. So they could absorb or release energy and do that. And this is our modern atomic theory. Okay, so there's a couple of people that were involved in this. Chadwick was one, Schrodinger is one, Heisenberg's one. But anyway, what's unique about the modern atomic theory? First off, Chadwick discovered the neutron. Okay, so you had these subatomic particles that had no charge that were in the nucleus, and then the electrons, instead of being in these, orbits like Bohr's model, like planets orbiting a sun, it was a cloud. So the electrons were just flying around the nucleus, not in, discrete circular orbits, but you'll see this kind of drawing. Okay. Okay, last part, isotope. Atoms of the same element with different masses due to different numbers of neutrons. Okay. An ion is just a charged atom. A cation, like we said before, cats have pos, so it is a positive ion due to loss of electrons. So as you lose negative things, you become positive. And an anion then is a negative ion due to the gain of electrons. And that's it.